Hello everyone and good evening. I apologize for the slight delay. I'm basically just back from work to put it shortly. So today we'll be trying to implement the genetic fuzzing algorithm I discussed on the last stream. So if you didn't see the last stream, then you might be a little lost. But yeah, if you want the theory behind it, then basically just watch the live stream from last week, which is archived on my channel on YouTube, obviously. Now, as you can see, it's a little lighter today. It's like finally summer, and by summer I mean there was snow a few days ago. But yeah, it's even though it's 8 p.m. here, it's still light outside, which is quite cool. Now, I would like to, as always, thank KrzaQ, who, where is it? Oh, here. Who is today's moderator, and he's helping me. So that means if you have any questions during the live stream, then just ping this guy either on our YouTube chat or on our IRC channel, and he will telepathically let me know that you have a question, and I will try to answer it if I'm able to. Now, before we get into developing the fuzzer, I'll do the usual updates, not a lot of them, well, a couple of them, I guess. I need to disable Steam first. Okay, perfect. So let's switch to the desktop view. Okay, so let's start with, as usual, this is KrzaQ's blog. Oh, it seems I have my Zoom It tool disabled, so I need to enable it. I apologize for that. Okay, it's enabled now, perfect. Yeah, it's like the usual dev.krzaQ.cc. If you're into C++, you should totally check it out. Hopefully there will be new blog posts somewhere in the future. Now, as usual, also, I would like to recommend subscribing to Live Overflow. Live Overflow has this awesome channel about CTFs and security, and he actually uploaded a video how not to ask a technical question. If you're just beginning with IT, it's a good thing to watch, basically. I guess I have my own share of horror stories about, well, how sometimes questions go wrong that you're being asked, but let's leave it for another time. Check out the video, it's quite funny. Apart from that, I would like to also give a shout out to Mormus CTF. It's a new channel, a new person who's doing quite a lot of live streaming from recent CTFs. As you can see, in the last couple of days, he actually has quite a lot of videos uploaded. It's like 1 week, 2 weeks, 6 days ago. He streams way more than I do, and check it out. It seems pretty awesome. Apart from that, I actually wanted to recommend this channel, which is called Retro Game Mods. It's actually my favorite electronic engineer that I really love watching. And this guy has a really awesome channel, so I just wanted to let you guys know. But yeah, this is something I love watching. Maybe you'd like it as well. Okay, now the hottest topic, I guess, this week is surprisingly not the DEF CON CTF, but it's the Intel AMT vulnerabilities that were discovered. And I guess if you were living under the rock, you didn't hear about it, but otherwise it's all over the news. Long story short, there's a topic on Reddit. There's basically Intel active management technology, blah blah blah, information page from Intel. Then there is also a Mythbusters page already on it about some. Well, there's a lot of talking going on about it, and not everything is fully accurate. So check it out as well. Now, what is AMT? And I actually wanted to go to Alexander and Rafał's presentation from 2009 from Black Hat, since I guess they introduced ring -3 rootkits back then. Basically, the idea is that you have this chip on your motherboard. It might not be this chip, it might be some other chip, it might be even in your CPU, depending on the model, and it might not be there at all, but it's basically a web server with a management interface, which is totally separate from the main CPU, and yes, there's a web server running on your motherboard, basically. And, well, it's there for, administrative purposes, meaning that if you have a data center, you can just connect to the web interface of the motherboard, check if the CPU is alive, check if the hardware is alive, and do all kind of management stuff. And security researchers were wondering for the last 8 years at least, if not more, if that thing is actually safe, because, you know, having something running on your motherboard, which is a web server with some software installed there, which well, is serving administrative purposes and probably has DMA access as well. And if something has DMA access, it has access to RAM, and if something has access to RAM, it has access to ring 0 of your CPU, and actually even the lower rings, right? So yeah, it's quite scary, and some vulnerabilities surfaced. Basically, take a look over the internet. There are quite a lot of interesting articles about it. So yeah, that's it. And I'm not going to go into the details, just, you know, check it out. Last thing, there was the DEF CON CTF qualifier last week. It was actually really hard. I do have somewhere I have the screenshots of the scoreboard. Yes, here it is. Okay, so we didn't qualify. Like, first time in 3 years. I'm actually quite sad about it, but yeah, it happens. Quite a lot of awesome teams did qualify. I mean, PPP already had qualified some time ago, but yeah, like, congratulations to everyone. We finished actually down here on 19th place. Score-wise, it wasn't bad. It wasn't great either. We had basically the last day, the second day of the CTF, we had quite a lot of challenges really close, and we didn't manage to finish them. It was quite funny with the Godzilla task, for example, because it seems we misinterpreted the way which part are we exploiting, and we tried to attack a different bug. In the end, it was a fun CTF, really pawn heavy, meaning that if they actually even had a category like web challenge, and the web challenge was actually like a web server, which was actually, you connected there with Netcat and you just chatted like a normal pawn challenge. So it wasn't a web server. It was a web server, but it wasn't used as a web server. It wasn't a web challenge at all. It was just a pawn challenge anyway. There were quite a lot of fun tasks. I'm not going to go into them today. But yeah, maybe later, like next week or so, we'll see. Anyway, congratulations to all the teams who qualified. So I guess that's all in terms of news, so we can get to the main subject, unless there's already some question. I don't see any questions yet, so we can get going. Okay, I see KrzaQ is pasting the links to both channels. Thank you. It's something I try to remember doing before the stream, is to give my moderators the set of links I'm going to use so they can give them to you. And thankfully they are doing a really good job. So where did we finish last time? I did... sorry, let me open the directory. I did discuss, well, I did tell you basically how the genetic fuzzing works, how it differs from normal fuzzing, from dumb fuzzing, and today as promised, I'm going to implement the fuzzer itself. I just need to find my directory with the source code. So there are two pieces of this equation, I would say. Actually, the fuzzing system itself, and the way you get the traces, the edges, or the blocks which the application follows from the application itself. And I mentioned them already. For tracing, you can basically use a set of various mechanisms which are, well, either software-based or hardware-based. And by hardware-based, I mean actually there are some Intel CPU features. I'm not sure about AMD, I actually don't know. I am sure about Intel that there are a set of features which basically the CPU, you give it a buffer in memory, and it records all the basic block addresses which it traverses, or all the instruction addresses. In the end, it's actually a kernel feature, so your kernel has to support it and give this as an API to the user, and I believe Linux kernel does it. So that's one way to do it, basically do the tracing using the new hardware features which are implemented in the CPU. The usual way is either to do black box tracing or to do software white box tracing, which means modifying the application actually and including pieces of code which do the traces, right? For example, if you hit a function or a basic block in a function, there's a piece of code there which says, oh, this block, my block was hit, therefore I am going to put it on a list of blocks which were hit, and I'm going to continue execution, and then the next block is hit and it does the same. So that's the way AFL does it. AFL is a set of, well, basically a GCC instrumentation. It adds instrumentation using GCC to the stuff you compile. Another way which I am going to use today is the address sanitizer. The address sanitizer is basically, let's call it an extension, a plugin for the compiler, which first of all, it detects memory corruptions and it detects them really well. And second of all, it also does trace recording for you and by adding things to the application. And that's actually quite fast. I'm not sure if it's faster than the hardware base, but it's actually really, really fast tracing. So that's actually really awesome. And the last method, which is slower, is black box based, which means you have a binary blob. You cannot modify the application, but you still want to trace it, right? And the way you go about it is, well, there work, and again, a couple of ways, but the usual way is you either do single stepping, and I don't know if you know, but actually in some CPUs, I believe in Intel CPUs, there is a not well documented MSR register, but if you send some value there, then the single stepping mode in a debugger switches from stepping through single instructions to stepping through single blocks, which speeds stuff up greatly. But yeah, so in the end, this is debugger based. You have to have a debugger attached, and you have basically the application, and you do single stepping by blocks, and you record each block which was hit. So that's one way. Another way is just, you have a list of blocks from, for example, from IDA, and you set temporary breakpoints on all of them. And a temporary breakpoint is a breakpoint that hits once and records that it was hit, and then just continues and is never hit again. It removes itself. So that's another way, and then there are ways which do actually in application hooks or instrumentation like DynamoRia or Intel Pin or some other hooking engines, which basically do the same, but within one process, or try to stay within one process one way or the other, or do it by some emulation and virtualization, and in the end to gain some speed over the solution where you have the debugger and the application running separately. Because if you have a debugger catching signals from the application like breakpoints or single stepping, that's actually slow because it has to go to the kernel has to wake up the debugger process, the debugger process has to wake up, do some stuff about it, and then wake up the target application and go to sleep again, which is somewhat slow. Anyway, so again, I'm going to use the address sanitizer method. Address sanitizer is built in newer versions of GCC as well as newer versions of LLVM. It's native to LLVM, meaning that in LLVM it actually does works great with LLVM, because all the newest features are always in the newest version of LLVM. Okay, where can I find the instructions for hardware tracing? So I'm going to actually give you a weird answer. The weird answer is go to HongFuzz. HongFuzz is it's double G, HongFuzz, and it's like Google/HongFuzz, and look, basically read the docs, go through it, because I'm sorry, my underline was terrible. Yeah, basically Robert Święcki, who is the author of this fuzzer, implemented tracing using these features, so you'll have a perfect example how it looks in, well, how you use them. And HongFuzz actually supports a couple of different variations of the features which were in the CPU, because depending on how new CPU you have, you might have some features or you might not have some newer features, which newer means usually faster. I'm going to also give you the link to both chats. Here we go. I think one is called, by the way, Intel PT, and the other, there's also another technology, but I don't remember the name, I'm sorry. Just do like install HongFuzz and do help, and it will basically give you all the options. Therefore, we should start to get going with the coding. Was I coding under Linux? I believe that was the case. So, okay, I think I even compiled the application last time with ASAN, just in case I'm going to recompile it. And the application itself was also a little funny. Let me show it to you. Here we go. It's funny because it's a set of ifs. It's actually, the indentation here isn't correct. Obviously, it should be like growing, but that doesn't matter. The idea behind this code was that a dumb fuzzer would only be able to like basically maybe enter here, but would never be able to get this condition correctly. While a genetic fuzzer will be able to basically go through all of these. And that's what I'll hope to achieve by the end of this stream. Now, what we want to do now is basically recompile this again and compile it with ASAN. So, do I have clang here? I do believe I do have clang, yeah. And I never remember, I probably already said these exact words last time during the stream, but I never remember how do you compile it with address sanitizer and coverage. Because there are some options you actually need to specify. I'm doing it a lot at work, but we use a little different method. Sanitizer coverage, that is, tracing PCs. We want edges. No, we want basic blocks, I guess. Let's start with basic blocks. Edges actually don't differ too much in LLVM, in ASAN implementation from blocks. It's still a list of basically basic blocks, like single addresses. Because usually when you have an edge, you have two addresses, right? You have like the source address and the destination address. In ASAN, it actually still is the only one address, and for some edges, because for most edges it's obvious, and for some edges where it's not obvious, for example, there are several sources which are going there, it just, I think, adds a virtual basic block to that edge, and thanks to that, it actually can output less data. Still, let's focus on basic blocks for today. Do I have to specify any other? I think I have to specify some other argument. Okay. I think it's like this: f sanitize address. Okay. Okay. Yeah, that's fine. Let me change this instruction because I'm a little afraid it will optimize it out. So I'm going to change it to abort. Abort will just crash. Do I need to include something? I need to have a stdlib here. Okay. Now let me recompile it. It doesn't complain, which is perfect. And I can test it by running. I have to set this environment flag called asan options verbosity equals 1. This is basically a repetition what I did at the end of the previous stream. As you can see, it works, and I'm going to also enable coverage, which is you just do coverage equals 1, and as you can see at the bottom here, it did dump the coverage. It written only three PCs as in 3 addresses, because I didn't pass this argument, which means it tried to open a file which was basically called null, and it failed, so it returned. So these are like 3 basic blocks here, and it never got here. Obviously, if I would pass on some argument with an existing file, it would actually pass, right? And as you can see, more blocks are written. Now I'm going to open the coverage file in a hex editor, so we can observe how it looks. And all the addresses, since I'm running an 64-bit process, all the addresses actually have 8 bytes, 64 bits, obviously. And these are the actual addresses which were written down. Now, I did on the last stream show how an IDIDE looks like, and you could see that there are quite a lot of basic blocks added by ASAN itself, but that doesn't matter. What matters is for us is that these addresses are unique, which means it's actually important for us, because what we will be looking, we won't be analyzing the addresses themselves. We will be treating them as a unique identifier for a basic block, and that's all. We don't care how they actually look like. Now, there seems to be a comment, or yeah, there are a couple of questions, so let's go quickly through them. I can use CLang format, KrzaQ says, to format my sources, or format KrzaQ. Let's test KrzaQ's website. Why not? So okay, copy paste fail. Style WebKit Google. That's nice. Yeah, this is how this program should look like. I am going to copy paste it because it looks funny. So thank you, KrzaQ. Okay, then there's a question. So Dragon Sector isn't able to qualify for DEF CON finals anymore for this year. Yes, that's correct. We're not going to Vegas this year, which I guess means we will have save some money, which isn't a bad thing in the end. But yeah, I believe our team would like to go anyway. But yeah, you know, we have to do better next time. Any chance you could do a live stream about using symbolic execution frameworks like Angular? At some point I will do it, not yet, because I don't feel strong enough from that to actually be able to speak with confidence about it, so not yet, but at some point, yes. I saw the American fuzzy lob is a genetic type of fuzzer, is that correct? Yes, by all means. I think that was the first fuzzer which actually implemented this. So actually, this is somewhat unfortunate, but I did make a live stream, a 2-hour live stream with the author of American Fuzzy Lob, which is El Kamtav, or Michał Zalewski, but it was in Polish, because we both speak Polish, and I did upload subtitles made by Piątkosia for the first part of it. The subtitles are in Polish, but if you upload subtitles, the automatic translation to English actually is really, well, way better than you know, trying to understand, doing voice recognition and then translating it. So if you actually go to my Polish channel, you might be able to even enjoy a little the it's YouTube/user/Genveil Coldwind, and these two, like fuzzing with El Kamtav part 1. It has again subtitles uploaded, so if you open it, if you go here, enable subtitles, and go to auto translate, you can select English, and it isn't terrible. It's understandable. It has some problems with English words used in Polish in a Polish way that get translated back to English, but apart from that, it's pretty decent actually. So check it out. Okay, I guess I'll go for one more question, and then actually 2 more questions, and then I'll jump into coding this. Hey, I'm kinda new to hacking, practicing with CTFs from VulnHub, but very often I get stuck at a point. Mostly, I don't know how to get a shell. How do I practice this? So it's like this. If you're just beginning, a good thing to do is to read write-ups for the challenges you are solving, or like walkthroughs through the challenges, and look how the person did it and do it yourself. Look how the person did it, do it yourself. You learn, you get basically a knowledge database in your head that way, and you also install the tools which are needed. You will get to know about the tools that exist. You get to know about a lot of other stuff, and then gradually basically put the write-ups on the side and stop looking into them unless you actually get stuck, and try to do more of the stuff yourself. And finally, just don't look at the write-ups at all. Do the challenges, even if you need to Google 2 days to find what you need to do. Do it like this. But again, start with something which does have write-ups, and for challenges which do have solutions with a full description how to do them, and then gradually move into the area where you don't look at the write-ups at all and you're fully doing it yourself. That's my recommendation. And I actually do a lot of them, and by a lot I mean do like 50 or 100, because it takes time. It will always take time to get to know stuff. Okay, what kind of fuzzer is pitch fuzzer? That's actually a good question. So pitch fuzzer is it's a older kind of fuzzer, I would say. I didn't use it at all, actually. I looked at it once or twice. From what I remember, it has somewhat decent way to describe how a protocol looks like, and then use that. Now, genetic fuzzers are somewhat different from that because they try to, by random, determine how the protocol looks like, and so it's like different animals. Both types of fuzzers are useful, basically. Genetic fuzzers even more, I would say. But again, I didn't use speech to match. It might have genetic fuzzing implemented. It might do some other magic which AFL is not able to do. I have no idea. So yeah, but it exists and it's been there for a while. Okay, cool. I guess we'll do, by the way, today a short break, in about like 5-minute break, and then, but yeah, maybe now. Let's do it now. 5 minutes. I need to get more tea. And then we jump back into coding this, so I'll leave you with some music and be right back. Where's the music? Oh, here it is. Apologies for the break. I actually, when I have dry throat, it's like not comfortable to speak, so that's why I decided to take a break so we can get the stream going. And yes, it did say 3 minutes still, but I guess in 3 minutes say what. Maybe you can use this for questions. Are there any questions? Yes, we can use this for questions. Will I talk about shadow breakers this week? Brokers, you mean, I guess. No, not yet. Sorry, I didn't look into it. I guess it's like, I know what's going on, but since I'm not involved in any way, I don't really have too much motivation to actually look at it. One more question. Why do you use Hex Workshop and not 010 Hex Editor? What's 010 Hex Editor? I believe I did look at it. Maybe on last stream or on a Polish stream? I don't remember. What's a nice Hex Editor? Yeah, I believe I did look at it last stream, right? Oh, I know what we can do since I have still 2 minutes left. Anyway, there's no reason. I never used it. If I would, I have to check it out. Basically, that's the answer. Hex Workshop mostly works. It crashes sometimes, but it mostly works. I'm going to save myself a link. So, yeah. Okay. So I'm going to use the remaining 1 minute by going to my own web channel, because as you might remember or not, actually at the end of the last stream, what I did was I gave you a mission, and the mission was basically this. So there was, if you like lasted until the end of the live stream, or actually looked at it on afterwards, there was a simple mission which was actually a small CTF-like task where you had to do some crypto in this case. And actually after this video, today's episode, there will be another mission, so if you liked solving those, then eventually go for it. Now, I think KrzaQ was actually the first person who did solve it, and that was the correct answer. The question was basically, let me open it and maybe in a better quality. I'm going to quickly explain it, and then we can call the break over and get going. Anyway, so yeah, basically the mission was I took two English words, both of words were, I think there was, 8-letter words, and then I calculated MD5 of them, and then I XORed the MD5s, but in binary form, not in the hexadecimal form. And then this is the result of XORing it. And the question is, what were the two words? Now, there were, I guess, basically 1 or 2 ways to do it. I guess the easiest one would be to MD5 or all the English words. Basically, you do have to have an English dictionary. If you're into crypto or into CTFs a little, I guess you have on your drive like a dictionary directory, and you can then there have some English word dictionaries, like this one, for example, right? It's just 1 megabyte file of English words. It's quite easy to find on the internet or make your own, just going through Wikipedia, writing some script to basically like uniqueize the words and so on. Anyway, so you take such a dictionary, you take all the 8-letter words from there and you MD5 them, and then you take that each MD5 of the words, and you put them in a set, basically, a map or a dict, but in a set is basically a dictionary without the value part. It's just, you can quickly check if something is inside the set, and that's the main reason the set exists. Or you could actually do a dictionary with having the MD5 as the key, and the value would be the word. Now you go through this list of MD5 English words, 1 by 1, and you XOR the value with this, and what you get is, should be, if you hit the correct word, should be I'm going to call it a hash, an MD5, of a word which is in that set. So you basically XOR calculate MD5 of a word, XOR it with this, and then check if the result is in the set in your dictionary, and if it's there, then you found the both words. Basically, you don't know which one is the first and which one is the second, but that doesn't matter. So that was the first mission, and congratulations to everyone who solved it. I think there was quite a couple of solutions posted in the comments, so thank you for doing that. Wojciech, for example, posted his own solver, which is on WKLM Livestream mission, so you can look how he solved it. Yeah, I guess there's another solution from Marcin Bury, and I believe KrzaQ also posted his own. So yeah. Oh, there's a question like, can I share my brute zlib which I showed? I'll try to remember to post it on my GitHub later on. Yeah, so if you solve today's mission, the one which will be at the end of the stream, also please by all means post it in the comments down below. Like if you post an article about it, a blog post, or just your code which solves it, just put it in the comments. I like to review such stuff, look how you solved it, because your solutions might be different than mine, and that's the way I also learn. So yeah, okay, so end of the break, let's get back to the main topic, which is again genetic fuzzing. And my fuzzer currently looks like this. What's the name of my fuzzer? Is it Go? No, it's not Go. Oh, I'm actually changed the directory. So my fuzzer is fuzzer. Yeah, that's the proper name. Where's my mouse? Okay, here we go. Okay, now it has mutations and so on and so on. Now what I'm going to do is I'm going to actually remove GDB from here, and I'm going to run it again all by myself, because there are a couple of reasons. One of them is speed. I actually don't care about GDB detection too much anymore, because ASUN actually catches most of the crashes which GDB does. Not all of them, but most of them. So it's sometimes, usually the way you would do in a fuzzer is like, try to detect if the application crashed and if ASUN actually generated a report, because ASUN generates a nice textual report that, hey, it crashed, that was the reason. And if it crashed but there is no report, then run the application through GDB again. So that way you save time and not run it through GDB all the time. So instead of this function, I'm actually going to do another one, which is also called, well, maybe I shouldn't comment it actually. Let's call it run GDB, and I'm going to call my run ASUN, like coverage. Yeah. Here we take an executable name, and then let's create the subprocess basically in the same way. But obviously I'm not going to run this here. I'm going to use the executable, and then I'm going to put, how do I put the, oh, it's always called input sample. Okay. No, the input sample is this one, the test sample is our mutated file. So we put it, I have absolutely no idea what just happened. Yeah. Test sample, but that should be okay. So I'm running the application with this. Now I need to change one thing. I need to add environment variables, because I need to run ASUN coverage as well. So how do I add environment variables? Startup info used by popen. What is there? Oh, that's a Windows one, so that's not what I'm interested in. But the popen, right, the popen is the object I'm looking for. I guess the constructor is the most interesting one. Here's the constructor, and the none. What does this mean? I guess it's the, it's probably environment variables. Can I somehow copy them? What I'm interested in is if I set this value, like the end value, to a list of variables, will it be only these variables, or will they be appended? I probably guess it's going to only be the list of these variables. So how do I get all the environment variables in Python? Because I would... Oh, this sounds perfect. Okay, so let's do... Actually, I'm going to run Python now. Environment, sorry. Yeah. Okay, and this is a dictionary. A dictionary is fine. I would still love to know what this env here is. Env is known. It must be a mapping that defines a mapping. A mapping sounds like a dictionary. Okay, so that means it doesn't append these variables to the current set, which is I guess as expected. I'm not really surprised. And a mapping. So let's see if it actually works with us environ, and then I'm going to add my own. So okay. Then we communicate through a pipe. Then we don't care about this too much. But I will want to print the output, and I guess the standard. Yeah, standard error as well, because we not. And I'm going to return none for the time being. I'm going to add some code later here. And what we do here is it runs with coverage, and if the output is not known, then it assumes there's a crash, which is okay. So let's see if this works. This should just execute the application, not really do any genetic fuzzing just yet. So a couple of questions. First of all, why am I not using a shebang here? And second, do I have the format set to Unix? Okay. Now I can probably just do fuzzer. Yeah. No such file or directory cannot execute. I was running this under Windows. That's funny. Now I'm going to run it under Linux. Not that it matters. Yeah. And out is not the proper name. Why is it not the proper name? It is the proper name. Do I really have to do this? Are you serious? Yeah, it is serious. Okay, now where is the enter coming from? Oh, it's probably from here. So if output, then print output, otherwise if error, no, not otherwise, if error, then print error. But we don't want spam if it's not, yeah. So it's way faster now, and the speed is the important part here, because I wouldn't be able to show you the genetic fuzzing actually going through all these checks if it wasn't fast enough. So, and I'm not using any fork servers and other cool hacks like that, so I do have to care about the speed a little. Now I'm going to add the environment variable, which I did already tell you. I guess we can do... Can I just add to this dictionary? Let's see if it works. It's probably going to modify my own environment variable, at least I hope so. Let's do, just for checking, the verbosity equals 1. Okay, yeah, it works, perfect. So I did modify the parent's environment variable as well, but I absolutely don't care, that's okay. So I'm not going to do verbosity, I'm going to do coverage, though coverage equals 1. Okay, so it does go, and I already have my directory spammed with all these SunCoV files. Now I do believe there's an option in ASUN actually to tell what the file name should be of the coverage. So this is the data format, which I'm not interested yet. Oh, there's actually a tool which you can use to symbolize the coverage, which is useful for maybe analyzing your corpus and also for tracing some bugs, but I'm not going to use it today. Coverage directory, which is exactly the thing I need, so I'm going to create a directory called cav, as in coverage, and I'm going to specify this option as well, and I'm going to do cav here. Now let's see if it works. First of all, okay, it works. So I'm going to remove all the files from that directory. And now I'm going to do it like this. I'm going to run the application, and I'm going to check if in that directory there's actually a cav file. So I'm going to import glob, actually from glob. Import glob. Glob is basically a file enumeration tool, but that's about it. Well, tool library. It's about there is to it. Cool. So now. For cav in glob. And again, you probably know this because I'm repeating this a lot of, well, almost every time, but I'm not really writing production quality code. I'm writing code which I can write fast, and that's about all I can say good about this code. So if I would write this code in the production quality, this would be a configuration option somewhere, and yeah, probably I would do some checking if I could actually name this file in the proper way. Now I need to read this file, and I need to actually I'm going to create a function get coverage that just gets the coverage, and let's call it C. And then I need to remove the file. How do I remove a file in Python? Python unlink. In what directory do we have unlink? Okay, os unlink, remove the file, blah blah blah, perfect. That's exactly what I need. I already have os imported, so I can just do this. Okay, now I'm just going to print the coverage name for the time being to see if it works. And there should be at most one. What the hell? What did I get wrong? Because it. Did I get the get directory name wrong? No, Sankov. Yeah, I did the extension wrong. Yeah, now that's okay. Yeah, perfect. It seems to work now. Let's do ls again. There are no files. Perfect. That's exactly what I wanted. Therefore, I'm going to... Oh, I need to do one more thing just to be sure, because sometimes when I, press Ctrl-C and break the process might be broken somewhere around, like, between these lines, which I've marked. And that means that the Sankov file will be present, but it will not be removed. Therefore, if I restart the fuzzer and we go through to this loop again, we'll actually find a Sankov file which is already in the directory. Now, in a proper fuzzer, you wouldn't probably look like all the Sankov files in a coverage directory. Instead, you'd actually know what's the PID of your child. And please see that please note that the file has the PID, the name of the executable, and the PID in the name. So I could just use that, but I'm lazy, so I'm going to use glob. And since I'm going to have to use glob, I do need to do this. Basically, I need to remove all the files once I begin the fuzzing all the coverage files. Okay, cool. So now I need to get the coverage. Basically, this is going to be easy. So you need to open the file. Read binary. Obviously, reading binary in Python 2 in Linux doesn't differ from reading the file, just in normal way. Okay. F. Yeah, and now F read. I'm just going to read everything. I'm going to call it cov. Now what I need struct. Oh, I have struct already here. Perfect. So I'm going to... What I'm creating actually is a set, I guess. KrzaQ says there are questions. Oh, quite a lot of questions. Okay, I believe I didn't remove one. Okay, Dohan says that I could just use popen.pid, so there's a .pid property within this object. I could use it, I'm lazy. Do I ever use IPython? Yes, I just forget to run it. But yes, I have it installed. I really like it. And I usually just type Python because I forget to type IPython, but it's really cool. Okay, I guess Dohan also says that OS environ is just a dictionary, which is correct. And there's a question, can you please ask how does he go about any crypto challenges during CTFs? Oh, that's actually simple. I do like this. Hey, Adam, are you free? There's a crypto challenge. No, Redford, what about you? Yeah, please take it. I'm going to take some other stuff. This is the way I handle crypto challenges if there are any of our Dragon Sector crypto guys on the CTF, because they are way better than I am in crypto. I usually can handle crypto up to 300 points, but they are just better. So this is the usual way I go about crypto challenges on the CTF. Now, if you are asking like if I am forced to, how do I handle crypto? It depends on the challenge. We might do some crypto challenges at some point, rather easy ones. Yeah, but it's a really long question and requires a separate stream to answer it. So I guess I leave it at that today. Okay, get coverage then. And there are no more questions at this time, which is perfect. Coverage. What do I need to do? I guess I need to go through all of them. So can I split it in 8 in parts of 8 in an easy way? Actually, that's a good question for you guys. If anyone knows a way in Python how I can split a long string into strings of exactly 8 bytes without using for or without using the usual x and blah blah blah, or x for x blah 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 notation, then I would be really happy to learn. I'm going to use that notation though. I said I am going to return a set, right? So let's return a set. Because I can do all the weird fun stuff with a set later on. And yeah, so for x and I plus 8, and this is actually, I'm going to use not separate struct obviously, unpack and native endianness, but what was it wasn't I, was it Q? Let's see if it's Q. I'm looking for the format. Python struct unpack. I'm looking basically for a format for a 64-bit unsigned integer, which is Q. Yeah, I'm correct. Yeah. So this is the format, this is it, then for I in range 0 to len of cav 8. Yeah. If anyone knows a better method to do it, then please let me know. Okay, so this returns the coverage, if you believe it or not. I'm going to just output it, I guess, here for debugging purposes. So print C, and we'll see where we get. Yeah, and this is the coverage. Now this weird value here is actually one which I probably should skip, which I'm going to do by replacing the 0 with an 8. And this is the magic value at the beginning of a file. All the other values are actually values of which are being reached in a file. I guess if we run it for how many values are there? Like 1, 2, 3, 4, 5, 6. That's not a lot. Why are these files so short? Did I mess something up? The files should be a little longer, but why I'm considering whether it's... Maybe I'm not passing the argument correctly. Let me do like this. No, not. Okay, and now I'm actually wanted to see the length of these files. Yeah, we did trigger some longer files. Why are my files, which I am testing with now, not longer than that? This is, I guess, the standard way to... If I do this now without test... Okay, and I'm now curious about the both sizes of these files. So this is 120, and this is like the default test I run, right? And this is 32. This is somewhere in between, which is, I guess, good. Test, if I believe correctly, yeah, test reaches a couple of blocks, and so no, we're fine, we're fine. I was just panicking without a reason, I'm sorry for that. Yeah, oh, perfect. Now you can see that there are some samples which actually return this many iterations and samples which actually return less. And then there are probably some samples which will even return more than these, right? So let's try to wait for one which is longer. It will probably take a while, but there should be one. Because we are not brute forcing it byte by byte, but if we would, it would be a little faster. Well, okay, we'll have to test it later on anyway. So yeah, it works. That's the important part here. Now, once we have this, we actually need to keep the state as in the current best coverage, which means I need to do some intersections. How do you do Python set intersections? I have absolutely no idea how to do it. Intersections of two lists. Perfect, that's exactly what I want. Though not a list, really. I believe there is yeah. Okay. Let's see what actually the standard type set has. It has intersection update, is disjoint, is subset, is superset. Perfect. This is exactly everything I need. Therefore, what I'm going to do is I'm going to first create basically a global coverage. Actually, I'm going to move this down. Yeah, the quality of this code is non-existent. Okay, now I'm going to create a coverage set, like a global coverage. Let's call it global. No, just like main coverage. And it's going to be a set of all the places we've already visited. And now, if a sample, so I guess I need to do global. If a sample is a subset or equal to the main coverage, how does it actually react to? So if I create a set with 1 and 2, and if I create a second set with 1 and 2, sub. It's a subset. Perfect. I was wondering if they still call it a subset. So that's one thing, and the other thing is, which direction is it? Is it A a subset of B, or is it B a subset of A? So I'm going to again create A, which will contain only 1, and I'm going to test, is A a subset of, sorry, it's incorrect. Is A a subset of B? It is B a subset of A? It is not, because B has 2 and 2 is not in A. Therefore, if not C is a subset of main coverage, that means in the C, in the coverage we just got, there is at least one address which was not in the main coverage part. This means we just found a new coverage, node. Found new node, that's basic block, whatever. And this is cool Now we need to do a couple of things. First of all, we need to, I guess, add the, well, merge the two sets. How do you merge the sets in this language? Can I just do this? No, I cannot. Can I do union? Union. That's perfect. Okay. And let me just test if I'm interpreting this correctly as an SQL union. 44. Yes, this works exactly like I believe it should work. Therefore, now main coverage is actually going to be equal to main coverage union with the new coverage. I'm not sure this is the fastest way to actually go about it. If there's like an in-place union, maybe update does it. Yeah, update does it. So update will be faster. It won't be create additional objects in memory. Okay. Does it crash? No, perfect. I was wondering if it would complain that it already has these items in the set, but it doesn't. Okay, I guess there are some more questions, but I'm going to finish implementing this, then run the fuzzer, so it starts going through the samples, and I'm going to and then I'm going to answer the questions. Now, this input samples is actually something I'm going to include the current input sample to, which means I need to do. Oh, then that means actually, since I'm doing update, I don't need this because I'm not writing to it. Sorry, not overwriting the label. That's what I meant. This is going to be what was it? Append, and I need to append this new file which I just mutated, but I actually need to put it somewhere. I need to copy it, I guess. How do you copy in Python? I guess OS should have something. Copy anyone? No, not copy. So therefore there's something called shell util, which should have it. Copy, perfect. No. Copies the content, not the metadata. Yeah, it's okay. Import shell util. Okay, now shell util, copy file. First is the source. The source is obviously test.sample, and now the destination. The destination is I don't know. Input something sample. I have no idea what the something could be, but we'll figure it out in a second. Okay. This is just then length of the new coverage, because that should be unique within the fuzzing session, as it's always growing. So that's it, and then I'm going to append it to my oh, I actually should do it in a better way. Okay. Now, for the purpose of demonstration, I'm actually going to change this. Now what it would do is, for each sample which actually finds a new basic block, it would add it to this list. For the sake of demonstration and making it run faster, I'm going to change this logic, and actually I'm going to remove whatever is on the list, and now I'm going to, and then I'm going to do it, because this way I will get the fuzzer to focus only on the newest things it found, and the newest thing it found will be always, you know, getting deeper and deeper and deeper into this, and finally hitting abort. Maybe instead of hitting abort, I should do something else. I should, like, for example, do a infinite loop. But yeah, that shouldn't matter actually. So pub0 is it the thing I'm looking for? So 1 pub. Yeah, that's exactly what I was looking for. So yeah, comment this out. Okay, and this should be actually it. This should find a sample which adds a new basic block, and then well, mutate the sample which finds a new basic block, and then copy it and then add it to the input sample list. Now, my logic, how does my logic from selecting the input samples work? The input sample is a random choice. Perfect, which is good. So, yeah, let's see if it runs actually. Do I need to? I think that's actually complete. Like, there will be nothing more here. I'm just going to, I guess, put this as the length of a main corpus. Okay, and I'm going to let it run and see if it crashes. Perfect. Why did you crash? It does not support item assignment. Found new basic block 0 because we don't have anything yet. Why? Oh, it's before the update. I actually need to do it after the update. Okay, found 6 new. And then it crashes for... I guess I could also put the file name here. Just for debugging purposes, obviously, and it's called input sample 6. Now let's see what's weird about this file. And there's nothing really weird about this file, I guess. No, it looks pretty normal. So, why does it complain? Oh, right, my bad. I actually should use load file there. I put the name of a file there, and what I actually should have done is I should have put the content of the file there. So yeah, my bad. Okay, and it works, and it fuzzes, and let's see if it finds a new basic block soon. If it does, then I'll just go into questions. I guess I can make it simple for it and actually remove some mutators for now. I'm going to remove this one and remove this one to speed it up, just to speed it up, because I know what I'm looking for. I'm also going for magic bytes. I'm going to change the ratio. Oh, no, the ratio is actually okay. It's 1. So yeah, so it will be faster. Let's see if it actually just finds a new basic block. If it does, then we'll get. I guess I can start doing questions now, and we'll see if it actually finds a block or if I do have a bug in my code. Okay. So something, Dohan suggests that something might be PID. And by something I guess you mean the name of the file. It could be PID, but PID isn't guaranteed to be unique. The operating system will reuse the PID. So, no. Okay, then there's a question. Hagenvale, I was wondering what you thought of DEF CON quals this year. I guess as usual, I mean, they were binary heavy, which is normal for DEF CON qualifiers. And apart from that, the tasks were quite messy, I would say. Not super hard. Well, they weren't easy by all means, but they were messy. Like, there was a lot of reverse engineering to do. There was, basically it's like this. If you have a pawn challenge, right? There are 2 ways to go about the challenge, about creating the challenge. One is create a huge binary and make the person reverse engineer through the challenge to find the bugs and then make the exploitation hard. The other way is you basically hand the bug to the person, like, hey, this is like a 10-line function, there's a bug here, and like you cannot miss it, but the exploitation is really, really hard. I prefer the second type of challenges, and DEF CON was mostly the first type of challenges. That doesn't mean they're bad or anything. They're more real world, I would say, thanks to that. But yeah. So in the end, I liked it. I obviously was quite disappointed and quite sad that we didn't qualify, but apart from that, I mean, the CTF itself was like good quality as always. These guys really do a good job each year. Okay, now why didn't it find even one single block yet? I'm going to start, I guess, checking the... So this is the initial input file with A's alone. Let me do a couple of things. First of all, I'm going to look for... yeah. Okay. Coverage, and I'm going to run it with input sample to see how many... 6 PCs, which is exactly how many we get, which is correct. So we get the correct number. Now the question is, why doesn't it find yet any increase in that number? I guess the why is rather obvious here. It's since we are looking for ASCII values and these are not really, like it's looking for a wide range. So I'm going to again speed it up for the sake of demonstration by, since I exactly know what we are looking for, I'm going to do ort. Start with ort A and finish at ort Z. Or like, that's 61 hexadecimal, and I have absolutely no idea what Z is. It's like 7E-ish. Maybe less than that. Yeah, and this should be, now it should be faster. Okay. I'm going to like sneak a peek on what exactly is it. How? Yeah, anyway, no, it did already find a new sample, and it's like, yeah, it works. Now, so I'll get back to questions. So there's a question, could you do something like DFS or BFS through BB and ELF? I mean, like depth first search and breadth first search through basic blocks in an ELF. So yes, this is basically what the newest types of fuzzers are trying to do, and this is hard because it sorry, before I finish answering your question, I'm going to do one more thing. I'm going to actually do, like, move this here and do watch cat input. No, wrong. So we can actually see what's going on, like how it's finding the letters. It's not in order, obviously, the files here, but I guess you can see. Okay, so to get back to the question, the big problem here is that you have a basic block, right? And you need to answer the question, what kind of input do you need to generate to get to this basic block? And there might be a set of conditions which you have to fulfill to actually be able to get to this block. So how do you know which bytes actually to set to actually get there? Well, I guess there isn't an easy answer here. The way you might do it is through, for example, like symbolic execution, SAT solving, and so on. Therefore, having some smart way to actually be able to create, for example, a set of equations, which when you solve, you get the answer in form of a single input, which reaches exactly that basic block. This isn't a simple thing, but there are fuzzers that are attempting to do it, or other types of applications. For example, Microsoft Sage is one of, I think, the initial ideas which implemented this. And I guess some other fuzzers, especially after CGC started to do this as well. I guess like the Angular framework is also kinda helping with that. Okay, so as you can see, it's progressing quite nicely. We have already several letters. How many do we need? We need to go to up to P or down to P. And we are already at N, which is quite close. So yeah, that's a good question. And again, it's not an easy thing to do. Dohan asks, why only one try at a time? Try or go for multi-process. That's actually, Dohan has a point, and fuzzers scale really well. Dump fuzzing scales perfectly, and I guess we are like the next letter and we'll hit the abort. So dump fuzzing scales marvelously. Genetic fuzzing, a little worse when it comes to scaling, but still scales really well. So using multi-processes, several servers is the way to go. Again, as I mentioned, when we do fuzzing at work, we use, like, for example, 2000 CPU cores for fuzzing because it scales. So exactly what the Hans says, like using multi-processing here would speed up this fuzzer. But I'm not sure I would actually be able to like write it today, like change it. Maybe using my own multiprocessing. I'm not too familiar with the multiprocessing library in Python. That's a good question. Why didn't it hit the last letter yet? Maybe it did and maybe it's aborting actually. That's pretty possibly. Because we are not printing error code. So it's pretty possible that it's actually hitting the abort right now. How do we go about checking it? We should get the exit code. So I'm going to pause it actually. And I'm going to run it with here's a fuzzer. So I need the return code. How do I go about? Maybe instead of this dot here, we can do the error code. And error code is going to be a global variable, which will be normally 0, and it's actually going to be reset to... Okay, so how do I get the error code from... The error code as in the return value, obviously. Exit code, that's another way to call it. No, return code, here it is. But it's only for... No. I guess due to the KrzaQ. What? Why do you dislike me? Okay. And it has... return code, perfect. So it's actually better. So where did I do it there? No, it's here. Okay, I do hope this is not a function. And since I'm overwriting this label, I actually do need to do this. Okay, now let's run it. Yeah, and now it works, but it went from the start again. I'm not going to let it run from the start. What I'm going to do is I'm going to just grab this sample, well, maybe this one. Why not? And I'm going to put it in the input samples. Actually, a good fuzzer should obviously check the current, save the current corpus and restore it. Okay, and now it should start hitting abort from time to time. Maybe it doesn't. Okay. Let's continue with the questions, I guess. Maybe the abort is like it's running, but it's not really doing anything. Okay, moving it to RAM disk also speed it up, I guess. But that's true. Actually, in fuzzing, you try to. Oh, yeah, here, -6. So let's break it. Yeah, this is the abort. And having the error code, we could detect that this is a crash and actually modify it to run it through GDB and output it and so on. So yeah, the fuzzer is working. Basically, that's the assumption here. Well, not really assumption, that's the result of our tests. So I'm going to let it run just once more, because why not? And it will probably change some files. For example, you can see some random letters appearing. That's normal in genetic fuzzing, but not everything makes sense, but it does its job. So I'm going to continue answering the questions, and then we will round it up for today. Okay, the answer is that moving it to RAM disk would help. That's true. This isn't too much of a problem though, because modern operating systems, they don't write the file immediately to the disk unless you do not the flash. The flash instruction doesn't write to disk. The flash instruction flashes everything through a syscall to the operating system, but there's also a sync instruction which forces the operating system to actually write the file to the disk, or some operating systems actually have a flag when opening a file that actually says, yeah, basically always write to the disk when I'm trying to write to the disk. Otherwise, it goes to operating system memory, to the file system memory, and and then when it's being read again, it's already in memory. It's being because it's cached, so it shouldn't be a problem. But it's not RAM disk in this case. But when the corpus starts growing, the files are going to be evicted from RAM, because just to make place for different files. Therefore, it does make sense to use a RAM disk in that case. So the Hans idea is really good. Just catch the exception. There is no exception. I mean, if there would be an exception, you would see it. I'm not doing a try catch all anywhere. Would you start to play with Arduino's RIPs and Raspberry Pis and other stuff like that? For example, RISCure, CTF, RISCure. I'm sorry if I'm butchering the name. I have absolutely no idea what's that. Let's see. Oh, maybe I do have. I do know what it is. I didn't solve. Actually, yeah, why not? I mean, I do have some Raspberry Pis and Arduinos lying around. So, yeah, I'm kind of getting again into electronics and other stuff. I already have my small little, how do you call it, workshop set up. I can, I guess, show you a photo. Let me find a photo though. Yeah, I guess, for example. So I have now a basement where I can do soldering and stuff, and not really take out the soldering iron on the table, on the dining room table, like clean everything up and then put it back on the shelf, and that was really painful. And now I actually do have my own space where I can do this stuff. So there might be some more like electronics stuff in the future in the streams, but I am a beginner at this, so I might tell you how I did things, but that doesn't mean this will be correct or the proper way to do it. But I might sometimes brag, oh, I managed to solder two wire together, how awesome I am. Yeah, and I guess also doing CTFs for Raspberry Pis and so on, that sounds fun as well. And there's a comment from Light Armanov. The left to right evaluation order of the iterables is guaranteed. This makes possible an idiom for clustering a data series into n-length groups using zip and some... Okay, I guess that's the answer to my question, my initial question. Let's try it out actually. So, okay, I guess I'm going to turn this off. Okay, how the hell do you use it? Okay, let's try to, so that's 9, 10. Zip, iter, string, 2. Okay, that's really awesome, thank you. That's a cool trick. I need to note it seriously. Okay, and I guess that was the last question, if I'm not mistaken. So I guess one last thing which I didn't mention on my English streams, but I can do, is I bought a book like this. I'm sorry about the... I'm going to, sorry, flip it again. Yeah, okay, yeah. So this is assembly poetry. Actually, if you're watching my Polish streams, I already showed it. But long story short, it contains like small assembly snippets. There's nothing more on the pages. There's nothing more in the book, just like these small assembly snippets. And there isn't even a comment what does this do. It's like, these are in the description, I believe it says something like, these are like the snippets, assembly snippets, which the author of this book found interesting. Now, actually, some of the snippets are rather obvious what they do. For example, the first snippet is like different ways how to zero register, and I guess I can show it to you as well. One of these is really awesome. Yeah. So, like, notice the loop there, the loop with a $sign. That's actually, I had a good laugh out of it. So that's really cool. And this book is all about snippets like this. So some are really obvious, you know what they're doing, and some you're just like scratching your head and like, why would somebody write this code? Why would the person create it? What purpose does it serve? And yeah, so I actually recommend it. It's really cool if you're really into assembly and riddles like that. Okay, and I guess our genetic fuzzer again reached a solution which does the abort, does crash the application, therefore it goes through all these messages. So that's about it for today. I guess I can show you again the last input file. So this is input _34. It goes up to M, then there's O, and then the P is not here, but when it hits P after mutating it, it actually crashes, and since it crashes, it doesn't store a coverage file, and since it doesn't store a coverage file, it isn't included in the corpus, so that's actually fully expected. And again, thanks to this method, it's exactly like how modern fuzzers work, how they try to explore the application by randomly changing the input data and still preserving the samples which actually are somewhat meaningful to and allow the further exploration. So that's genetic fuzzing for you. Now, I guess the question is, what are we talking about next stream? So if you have any ideas, just put them down below in the comment area, especially when this video is archived, and you can put the comments. You cannot put them now yet. I see there are 2 more questions. Okay, what's this? For some reason I got a link to my logo. I don't... Dohan? What's the... Oh, is the feed secure? You're trying if there is XSS there. Yeah, I thought about it, so thank you for testing, but it should be secure. If you come up with a way to abuse it, then I guess the moderators will ban you, sorry. But there should be no XSSs there. What screen capture software does Gunveil use? I use open broadcasting software, which is, I guess, the default for streaming nowadays, right? So it's OBS, or actually OBS multi-platform. Yeah, it's this, exactly this. I've written my own plugin to display the intro, but everything else is basically, you know, stock, like including all these like flashing animations and feeds. That's actually the browser plugin, which comes by default, I believe, or you can just install it. It's a like basically a default plugin, which is Chrome running in headless mode, and you can just script it in HTML, JavaScript, and CSS. So that's about it for today. I would like to thank all of you for well being here, for watching the stream, and for commenting I'm also would like to thank obviously KrzaQ for being the moderator today. He had quite a lot of work, I believe. And yeah, and that's it. After I'm done, I'm going to leave you with some music and the second mission. So have fun and good luck, and see you on IRC if you're there between our streams. So thank you and have, I don't know, good luck with hacking. I'm going to upload the fuzzer soon to my GitHub. So that's it. See you next week, or actually tomorrow if you speak Polish. Bye bye.